Hello there. This is just a run through of the pneumatic setup that I've got in my featherweight Renegade. This is a low pressure setup, so it's running at just under 10 bar. I think I've got it set at for the moment. I'll just talk through what's involved in the system, explain a bit about the regulator that I use, and I'll go over some pneumatic fittings as well. So to start with, we've got the supply of gas in this bottle here. This is a 20-ounce paintball bottle, just standard paintball bottle you can get from online paintball shops and so on. It comes with a collar. Did I adjust this one? No, yeah. It comes with a collar for a paintball tap, kind of adapter tap, which is that there. So that's designed to screw onto the top of the paintball tank, and then you've got a thread in there for connecting stuff to. But this wouldn't allow me to attach the regulator, so that went bye-bye. So from the bottle, I've got this adapter tap which I found on a website online. This adapts the thread of the paintball bottle into the thread of this regulator, which is your standard CO2 regulator connection, or threaded connection on a big bottle. So the benefit of that, as well as connecting onto the CO2 thread, is it also has, or had a little tap at the top. I've then used epoxy resin to connect a 10mm nut to M10 nut, so that you can then use the tool to turn the gas on and off. However, as it transpires, this is nice and loose, so I can actually turn it by hand quite easily. From this tap, we go straight on to the regulator. This obviously drops the pressure down from between 750 and 1000 psi in the bottle to 8 to 10 bar, 120 to 150 psi it will run on. I'll go through the regulator stuff in a second. I'll just crack on with the system just now. But from the regulator, we've got the output connection here. This goes into a T-piece. From the T-piece, I've got a pipe that comes along into another T-piece. Off the middle leg of that T-piece into the elbow, we've got the pressure relief valve. So this is set, I think it's set just above 10 bar, so that if for any reason the system overpressurizes, this will blow and dump air or CO2 rather than causing damage to components. From the other leg of the T-piece that I've got at the back, it's not very clear to see, that just goes out the back into an elbow and into the dump valve to dump the CO2 after a fight. PRV and the dump valve are your main safety components on a pneumatic system for FRA rules. They must be in place. As is the tap for turning the CO2 on and off, this must be accessible, and you can use the hex tool that I showed earlier, but it must be accessible from the outside. And the panel on Renegade has a cutout hole there and some nice lettering to show which way it goes. So, coming back to the T-piece of the regulator, we've got the pipe with a bit of a kink in it, but never mind. Pipe comes down into 90-degree elbow to another T-piece. Seems like I love my T-pieces. Off the right hand side of this into an elbow is the connection to the buffer tank. This again is just a 20-ounce paintball bottle with an adapter in the neck that screws on to the push fit fitting under there. And all the buffer tank does is it stores CO2 at the regulated 10 bar pressure, so that when you fire the flipper, you're not having to wait for all the CO2 to come out the main bottle, through the regulator, into the system, through the valve and so on. It's already sitting there in a tank at low pressure, and it can just be dumped into the system immediately. All this pipework here on the whole system is 10mm push fit, so it's, I think 12mm you can go up to as well, but I thought 10mm seemed to be a good size, and it's the same size I use on shunt as well, and it seems to work fine. From the buffer tank, we come out back down to the T-piece. This is where we go into our solenoid valve to fire the flipper. So this particular model is a 12 volt solenoid. I am running it on 18 volts, 5S LiPo. Because it's just for short bursts, that's okay. You can't see it, but in there's a servo with a micro switch to turn it on and off. Very high tech, I know, but it works, although I will probably put a solid state switch in at some point. Solenoid valve is basically just almost like a triangle connection. When it's not actuated, the pipe going to the rams comes out of the vent and just vents to atmosphere, so if you move the ram up and down, it just vents to atmosphere, there's no pressure in the system there. When you actuate the valve, apply power to the solenoid, it moves down, and it then allows gas from the system in port P here, through to port A, which then leads to the rams. For this particular robot, I've got the two rams here, so the 10mm connection comes off, into a couple of elbows, and then if I just draw the rams forwards, I've got the elbow into a T-piece with a threaded connection to the first ram, and then an elbow with a threaded connection into the second ram. I figured this was the easiest way to connect the two up to get the same CO2 supply, rather than having two elbows coming off with push fit connections somewhere else. This seemed like the most robust and simplest way, so I've gone for that. And it seems to work. So just to do a wee quick demo, transmitter, that's already on. So we'll just turn the gas on, close the dump valve, turn the gas on. I'll just put it up to about half a bar. I'll go for one. So I've turned the gas on, that pressurizes the system. So all the CO2 that's in the system at the moment downstream of the regulator is now sitting in the buffer tank, and all this pipework up to this point here, where because the valve's closed there's no CO2 passing through to the rams. So if I just move the stick on the control, oh, you know what helps as well? If I plug the link in. So there's no powered retract in this, so it's just gas to fire the rams, and then the flipper and the bungee put the rams back down. On that one flip, you can see the pressure's already dropped quite substantially. If I do it again, and we're pretty much at zero. After the fight, CO2 off, and dump valve to dump the system. And so that's the setup for a low pressure featherweight pneumatic setup. So I'll move on to the regulator and some fittings as well. So the regulator that I use in both shunt and Renegade is this here. This is just a basic welding gas regulator on eBay that I got for £20. I'll pop a link either in the video or in the description. When this regulator comes to you, it doesn't come, I've got a 0 to 12 bar gauge on it at the moment. It doesn't come with this. It comes with these two gauges here, and they're set up just in a kind of Mickey Mouse style arrangement. The reason I've got rid of both of these gauges is the one on the right here is a high pressure gauge up to 300 bar or 4000 psi. That just tells you the pressure that's coming from your main gas bottle. So I don't need one of those because it's CO2, I know roughly what pressure it is, I don't care. So that goes bye-bye. This gauge, people smarter than me will be able to explain what this is, but it basically has 0 to 10 bar on it, which is fine. But then the two scales on this are CFH in litres per minute. So I'm assuming it's more to do with the gas flow rate than the actual pressure. But I'm not quite sure what the conversion is, and it's not particularly easy to work out. So I get rid of that as well, and replace it with a gauge that I can understand. What I've done as well is this gauge has a connection at the bottom. The one I've replaced it with has a connection on the back. So that allows, particularly in Renegade's case, for the regulator to be positioned in such a way that the gauge is visible. And also when this is in shunt, if the gauge had the bottom fitting, it wouldn't fit in the shell. So this just makes it a bit more compact. The high pressure gauge that was on it, I've just plugged that with a connector. I think it's 1/8 inch ports on this, so it's a 1/8 inch plug that I've just wrapped some PTFE tape round and put in there to seal it up. This part I think is the PRV. I'm not entirely sure, but I have heard gas pissing out here when I've turned the pressure up quite high on shunt, so I think that's a PRV, possibly adjustable, possibly not, I don't know. I don't bother with that bit. Last but not least, on these regulators, I've fitted this push fit connection here onto a 10mm pipe. The fitting that comes with this, you'll see it in the picture of the link for the eBay auction. It comes with a kind of barbed output connector on it, designed for pushing hoses on, I think for like homebrew, or even gas supplied to the welder, obviously. Rubber hoses that they push on and then put a Jubilee clip around to hold in place. The orifice in that is very small, so I unscrew that, it comes out quite easily. And again, it's a 1/8 inch connection in there, and that's just a push fit pneumatics setup. In Renegade, I've just swapped the elbow for a T-piece, same connection, same hole it screws into, but that just allows me to configure the system slightly differently. So that's all there is really to a regulator. For those of you in the UK, you'll know that there are the TREV regulators. They're effectively the same as this, but they're slightly smaller and they don't come with a gauge. But if you were to take the gauge off this, plug the hole, and have your connector on there, you'd be left with a regulator that's like maybe that wide and that long. Not all that much bigger than a TREV regulator, and these are quite readily available. So a good option if you're looking to regulate gas pressure down to low pressures. The other item I've got here is just another solenoid valve, another 3-2 valve. 3-2 just meaning 3 ports, 2 states. Your 3 ports being your gas in, gas out, and exhaust, and your 2 states just being on and off. And all you do is apply, what one's this? 12 volts as well. You just apply 12 volts to the 2 solenoid connections, and that will open the valve and let the gas through. Last but not least, this is just an assortment of pneumatic fittings that I've collected over the past year or so. We've got push fits, and we've got push fit to threaded connections, and various threaded connections and so on. The one thing to bear in mind, all these connections are imperial. When it comes to sizes on text sheets or websites, if it says, say for example, a 1/4 inch, that is referring to the orifice inside. There's a 1/8 inch connection, so it refers to the hole through the middle and not the thread on the outside, as I discovered when I accidentally ordered the wrong size. These are the main sizes that we've got: 1/2 inch, 3/8 inch, 1/4 inch and 1/8. And all I've done here is convert that to metric just for ease of referencing, and then the outer diameter of these threads. So a 1/8 inch connection, which is that, will be approximately 9mm diameter on the outside. And you're talking about 4mm difference between each fitting, so it's quite noticeable and quite easy to measure. So in terms of connectors, we've got things like Y connectors, which split one supply into two in a kind of compact way. TPCs, which do the same thing but at 90 degrees to each other. Elbows, 90 degree, quite self-explanatory. You do get other various push fits. Some of the ones I've got in here are threaded to push fit, and this is the sort of connector that goes into your regulator. So that's a 1/8 inch fitting, which is the smallest one, seems to be kind of commonly used. If you get this regulator from eBay, all the connections, the gauge, the push fit adapter and the plug are all 1/8 inch connections for that. One of the other commonly used sizes is 1/4 inch, which compared to 1/8 you'll see quite a difference in the size of the thread. These are quite common for your solenoid valves, so your gas in and out, they just screw into there. They all come with this white paste on them as well, which helps seal the joint, but I like to use PTFE tape on it as well, just to make sure it's definitely secure. A kind of bad habit from my gas engineer days. So that's elbows. You also get push fit the straight 1/4 inch connections. Again, these can go on your solenoid valves if that suits your setup and layout better. And other commonly used parts are push fit adapters with a female connection on them. This one is that a 1/4 inch? Yeah, that's a 1/4 inch one. Commonly used, I've got one, yep, on Renegade. The pressure relief valve is actually only from here to here, and the rest of it's screwed into a 1/4 inch push fit connection. Again, a lot of PRVs will be 1/4 inch as well, so just get a push fit to 1/4 inch and that'll be fine. And the other one, this is a 1/2 inch, I believe. I've got a slightly different variation of one on the buffer tank of Renegade. So this is a straight connection. The one on Renegade's just a 90 degree connection. And what I've got in the paintball bottle is an adapter like that. That thread there I think is M18 by 1.5, along those lines. So you can just drill and tap the paintball bottle for that, and then the 1/2 inch fitting on top, and then that just screws together. And that just allows you to use a paintball bottle as a buffer tank. A couple of other fittings here. This is all paintball fittings that I got with the system, but they're a bit iffy, so I don't like using them. That's just an on-off valve, but it didn't seem to seal the bottle very well, so I wasn't keen on that, which is why I got the adapter for the CO2 regulator. And then things like dump valves, just a 1/4 ton valves from, you might not get the thread types from Screwfix, but Bearing Boys Anywhere that sells pneumatic fittings, RS components, will have things like that. Most of these fittings were from bearingboys.co.uk. They seem to be one of the cheaper options. RS is a bit more expensive, obviously. The pressure gauge was from RS, although I think the last one I got on eBay. And the plug connections you can get from RS, but again you can get them cheaper on eBay. Solenoid valves can be quite pricey. I got quite lucky in the sense that all the ones I have were either donated by friends or bought as part of a system already, so they weren't too expensive. But yeah, I think that pretty much covers featherweight pneumatics for anyone who is interested. If you have any questions, just let me know and I'll do my best to answer them. Catch you later.